All right, so here we are, lesson 23. It says in this lesson, we learn how to use the quadratic formula to solve quadratic equations. And a little warning that this demo is kind of long. Let's see if we can get through it here. All right, so it says graph A represents the parabola for the quadratic equation y equals x squared plus 5x minus 6. I could have asked you to graph this thing today. This is just like the ones in the activity, right? So like I went through the process that you went through, and we get this parabola here. And then it says the two x-intercepts are located at -6, 0, and 1, 0. Now I've got some like graphical issues here. Your copy looks better than mine, right? Yeah. So -2, 0, what am I looking at? No, -6, 0 is there, and then 1, 0 is there. I think I'm in roughly the right spots. So then it says here, use the graph to identify the solutions to this equation, 0 equals x squared plus 5x minus 6. What you're supposed to see here is that this equation here and this equation here are exactly the same, except what letter became what number? Y became 0. That's the only change, right? And if your first step is letting y equal 0, then what points are you finding on a graph? You're finding the x-intercepts, right? Isn't that how we find the x-intercepts, is let y equal 0? So then the solutions to this equation must have an awful lot to do with the x-intercepts, which we can read from the graph, -6, 0, and 1, 0. So the answers here, x equals -6 and x equals 1. Those are the solutions to the equation. And let's make sure we see what's going on here. For example, if you plug in x equals 1, 1 squared plus 5 times 1 minus 6, I'm going to put like a question mark on top of that 0 equals. I'm hoping it's equal, but let's check. What do we get? 1 squared is 1 plus 5, that's 6, minus 6. Did it work? Yeah. And if you plugged in -6 for both of those x's, it would also work. You would still get 0. So there's a connection that I'm trying to encourage us to make here, is that the solutions to an equal 0 quadratic equation go hand in hand with the x-intercepts of that corresponding parabola. Solutions to an equation go with x-intercepts. Okay, so then it says part B, how can we find these solutions algebraically? Forget about looking at the picture. So in this case, it says you factor the right-hand side of that equation. So let's do that. 0 equals, I'm just going to tell you what you get when you factor, but I'm going to say ... box. Lots of work is going to lead to the answers that I'm just going to throw here. Turns out it's going to be x minus, turns out it's going to be x plus 6 and x minus 1. So go ahead and write that. It's okay if you don't see where they came from, but a big old box, you would get there in a couple of minutes. But if you're at this stage, if you're just solving this equation, what's the next step? You have 2 parentheses multiplied, set them both equal to 0, right? So 0 equals what? X plus 6, or 0 equals x minus 1, right? You just did that a bunch of times in graphing those parabolas. And then we solve this equation for x, move the 6 over, what do we get? -6. So we solve this equation for x, and we get 1. And in fact, yep, x equals -6 and x equals 1, exactly the same. So again, if you've got the picture of the thing in front of you, then you can just grab the x-intercepts. But if you don't happen to have the picture, then you go through the box method and you do the factoring and you solve for the solutions to that equation. Let's take a look at what happens when things aren't so nice. It says graph C represents the parabola for the quadratic equation x squared plus 2x minus 5. So take a look at this picture right here, a different looking parabola, and estimate the x-intercept. How about right here? 1 1/3, 1.3-ish, yes? Ish. And then over here, how much? -3. I heard a 3.4, I heard a 3.5, I'll just write that. Ish. But do we see it's a lot harder to tell what those are, right? We're just guessing. I'm just making our best estimate here. And so we can look at the picture and we can say, okay, using the graph, identify solutions to this equation. Again, it says 0 equals. So we've got 2 solutions over there. What's the first one? X is roughly negative 3.5, and x is roughly 1.3, right? I don't know for sure that those are the right answers. In fact, I heard different answers from you guys looking at the same point. So definitely these are not precise. So what can we do if we want precision? Well, you could factor, right? I mean, just like we did up here. Factoring didn't rely on having the picture in front of us. You just do the box and you get the factors. Well, here's the problem. This equation right here, 0 equals x squared plus 2x minus 5, does not factor. So you would do the box, you'd write the product, you write the sum, you'd list all the things that have the correct product, and none of them would have the correct sum. And we saw those a couple of classes ago where the thing just doesn't factor, and that's the answer. Doesn't factor, cannot be factored. Okay, so, but we'd still really like to be able to solve for x. We'd still like to know what the answers, what the solutions are. X equals roughly negative 3.5. I want to know more precisely than that. So how do we solve when we can't factor? So we use this magical thing called the quadratic formula. Here it is. Quadratic equation written in the form ax squared plus bx plus c equals 0. We've seen the a, b, and c already today. Has the solutions, and then here's this formula that you probably still have nightmares about once in a while from back in high school. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay. That's the quadratic equation, quadratic formula, sorry, quadratic formula. Okay, so we're going to use it in a second. Just a couple of notes before we do. That plus or minus symbol really combines two different equations into one. If we wanted to write it all out, we would really say x equals negative b plus, no plus or minus, just plus, square root of b squared minus 4ac over 2a. Or the other solution is x equals negative b minus, no plus or minus, just minus, square root of b squared minus 4ac over 2a. So the only reason we put that plus or minus is because we don't feel like writing them both separately, all right? It's just shorthand for these. These are the two solutions. Okay, so I'm going to encourage you to memorize the quadratic formula soon. If you go on YouTube, has anybody heard the Pop Goes the Weasel version of the quadratic formula? You can find, yeah. All right, that's good, Hugo. Thank you. You can find, there's this like really cute girl. She's like, I don't know, 3 or 4 years old, just adorable. She has no idea what she's saying, but she sings the Pop Goes the Weasel tune and recites the quadratic formula. So if that's your kind of groove, then go check it out on YouTube. I will say I want you to memorize it, but I will also say that on the coming tests and quests, I will just give you that magic formula there, right? But the better you know it, the easier it will be for you to apply it. Okay, so let's try using the quadratic formula to solve this equation right here. The solution is all written out, but we're gonna write it. Let's see if we have space. Not a lot of space. Let's see if we can squeeze this up here at the top. So first step is to put this into standard form, which means 0 on one side and descending orders on the power. Squared first, then the x by itself, and then the number with no x. So it's in standard form. And that's fine. Now we're going to figure out what the values of A and B and C are. Some folks are going to be able to do this in their heads without writing these things out, but I'm just going to write it out every time. How much is A, which is the number touching x squared? It's 1, it's invisible in this case. B is always the number touching x. It's 2. C is always the number with no x. Negative 5, and it's important we grab that negative. If you put 5, you're going to get it wrong. Negative 5. So grab the signs in front of A, B, and C every time. Okay, x equals. So here is our magic formula. It is written out right there. We're just going to start plugging in. I'm going to do the following. I'm going to write that formula, but I'm going to leave a lot of blank space. Really feel guilty like trying to squeeze this thing in here. It's one of these things where we kind of need space. I don't really know where to go. But how about right here? Can we just jump to the bottom of the next page? We got more space there. Just jump to the bottom of 192. That's where we're going to do this problem. Okay, so I will recopy and ask you to recopy. We said A was 1, B was 2, and C was negative 5. Can somebody just verify those are the right numbers from the previous problem? Okay. Okay, and now we're going to write, because we don't have it here on this page, the formula. So x equals negative b plus or minus, copy it just like I am, square root b squared minus 4ac, all divided by 2a. So write that whole thing. That's our quadratic formula. Okay, I'm going to put a step in right here that takes just a little bit of extra time. You don't ever need to do it, but for some of you, it's going to mean the difference between getting the problems consistently right and sometimes getting the problems wrong. I'm going to copy all of this stuff, except every time I see a letter, A, B, or C, I'm going to put blank parentheses. So first symbol is a negative sign, and then I see a letter B, and I'm just going to put blank parentheses. The next symbol is a plus or minus. The next symbol is a big square root. The next symbol is B squared. That B is parentheses. The squared is a symbol that I'm copying. What's the next symbol? One single symbol is minus. What's the next number? 4. But then the next two things are letters A and C, both get parentheses. Every letter just becomes blank parentheses. Divided by 2 parentheses. We just went to the bottom of this page here. We didn't really have room. We're down here. Okay. And now we are going to fill all of these parentheses in. But I think just having the shell increases the accuracy for a lot of folks in doing these. Okay, the first thing was supposed to be a B. What number goes in the parentheses here? 2. That is B. Next one is a B. 2. Next one is an A. 1. Next one is C. -5. Make sure you grab that negative sign. And then the bottom is an A. That is a 1. Okay? You can get away without writing those parentheses in. But sometimes people are going to make a mistake with their signs without all those parentheses. Okay, and now we're going to do some cleaning up here. No calculator on this until the very end. All right, the goal is to get rid of all these parentheses now that we've got them in here. So that's a negative, that's a 2, that's just the number -2. Plus or minus square root. Okay, that's a 2 squared, 4. Okay, let's think about the next symbol that we're going to write. It is either going to be subtract or add. Look at these 3 numbers that are getting multiplied together. There's a +4, a +1, and a -5, but the whole thing is being subtracted. So I'm just going to treat the subtraction sign and the negative sign as being the same. I have 2 of them. When you have 2 negatives, what does that make? Positive. And I think it's worth just pausing for 10 seconds like we did. Just make sure you get the right symbol. Is it plus or is it minus? And now that I've dealt with that, I can treat all these numbers as being positive. +4, +1, +5, multiply, and you get 20. 20 is correct. So 4 plus 20 is right. The danger is 4 minus 20. That's what I see sometimes. Okay, and then that's all divided by what number? 2. Easy, right? Just 2 times 1. Okay, the next natural thing that I see is cleaning up inside that square root. Single number in there is now 24. That's divided by 2. And sometimes that's the end of the process, right? We can't clean up anymore. There's nothing obvious right here. We've done all of the obvious combining and calculating. So for many problems, this is the full credit final answer. For this problem, there's more to do because we remember a couple of classes ago, I said, hey, we're going to do some simplifying on things that look like this. And the first step is to split into 2 fractions. Remember that? Split into 2 fractions with that plus or minus in between. I apologize. I think you guys are running out of room. I've got plenty of room. If you just hit the extend page button at the bottom there, you'll have plenty of room too. Yeah. Okay, so -2/2, it's going to get simplified, but I'm going to do it at the end. That square root of 24, we got to do work. And this is a kind of problem that I could have given you on the last quest. Simplify square root 24. So 24 is not a perfect square. So the next best thing we decided we could do was to find a perfect square that goes into 24 evenly. So what perfect square goes into 24? It's 4, right? So we're going to rewrite that 24 as a 4 times whatever is left over. 4 times what? Still 24? 6. And it's not about factoring 24 in any old way, you know, kind of willy-nilly. Like 24 is also 12 times 2, but the square root of 12 is nothing good, and neither is the square root of 2. But the square root of 4 is something good, which is why this is useful. Square root of 4 comes outside as 2. So I'm going to do a lot of copying and then one small change. Square root of 4 came outside as 2. Square root of 6 stays in there. And now we'll simplify both fractions at the same time, separately, but at the same time. Negative 2 over 2 becomes negative 1, plus or minus. The things outside the radical are both able to cancel each other. They just disappear, and we get that. Negative 1 plus or minus the square root of 6. Phew. Okay. We just solved a problem that we had approximate answers to before, right? We had like negative 3.5 and, no, what were the two numbers? You have them on the previous page. What is it? 1.3 and negative 3.4-ish, right? Okay, so now we're ready to actually figure out a much more accurate answer because these are the right answers. Negative 1 plus the square root of 6 and negative 1 minus the square root of 6. So I handed calculators out to some folks. And if so go ahead and grab a scientific calculator, either yours or mine. And I want to make sure that we can get this thing on the calculator. So for me, you're just doing them one at a time. Negative 1 plus square root of 6. And I think we had guessed, what did we guess? 1.4, 1.5 maybe. This is more accurate than our guess. And if we want to do the same thing but the other guy, we just do negative 1 minus square root 6. And this should give us that negative 3.4-ish. This is much more accurate than what we got before. Okay, now, the fact is, I would really, so this one became simpler because we lost the division, right? That divided by 2 ended up canceling in both fractions, but in many cases it won't. And so it's important to me that we can type it in even when it still has division, and that's harder to type in, and it's part of this process. So I'm going to clear this guy. I'm going to give you two options for typing this in: the safe way and then the risky but efficient way. So safe way first. Just type in the top, negative 2 plus the square root of 24. Negative 2 plus square root 24. Go ahead and type that in. Should get around 2.9. Everybody see it? Negative 2 plus the square. Okay, and now how do I finish my answer? Divide by 2. And don't retype that just right now. Hit divide by 2, and your calculator, even if it looks different, like a different screen, it will remember. It'll say, oh, you want the previous answer and divide it by 2, and we get exactly the same thing that we got before, right? And then the other way, obviously, is the negative 2 minus square root of 24, okay? The efficient but riskier way to do this, you can do it in one shot. I'm going to show you the wrong way. Don't do this. Negative 2 plus square root of 24. Okay, so you're going to find my error here. Divide by 2. I'm trying to do this whole thing in one calculation. So what's the first mistake? That divide by 2 is inside the root. It's not my fault. The calculator thinks it's smarter than I am. And what did it do when I typed the square root symbol? It put parentheses. I didn't type that parentheses, but the calculator did as a default. Okay, so I got to close the parentheses even though I'm not the one that put them in there. Okay, now it's not in the square root. Is this right? It looks okay. I know the correct answer is 1.449. That ain't it. Here's the problem. That divide by 2 is only touching which part? Only touching the square root of 24. So it's only doing it on the second one, but it doesn't have it under the first two, the negative 2. So if I want to do this right, I got to start with parentheses. And that's why it's easy to get it wrong, because there's no parentheses written there. But when you type it all in one shot in the calculator, the riskier but more efficient thing has to start with parentheses. So if you are into being really efficient, you can do this. Close the parentheses for the square root, close the parentheses for the entire numerator, and then finally divide the whole thing by 2, and we'll get the 1.449. Have I made it clear to you which way I think you should go? I'm hoping that you use the first way. Doing it the first way will cost you like 2 extra button presses. But I think you're going to get it right 100% of the time that way, and it's really easy to forget those parentheses doing it the efficient way. Nick? Fraction form meaning what? So are you talking about on the graphing calculator? Yeah, so I have like the old operating system on this graphing calculator, and the newer ones, yes, if you hit the division key, it will give you like a nice pretty fraction, and you can make it look exactly like that. That is less risky than what I have to do on my old OS here. But the fact is you are not going to be using a graphing calculator on the test and on the quiz, and so all you're going to have is the scientific calculator. So I don't think there's a way on the scientific calculator to make it look real pretty with the big fraction line. Okay. All right, so I think that is good. Let's make sure we got everything we needed to get here on the previous page. Okay, so we did all this. On the previous page, it does have screenshots just so you can refer to them when you're doing activities and homework, right? Those are the two. I think we should do the first way. You're welcome to do the second way if you really like those parentheses, okay? All right, so let's take a look. We don't have time to finish this one, but let's start it here. We're going to do this equation right here. So I think we're just on the top of this same page that we were working on, right? So we're going to solve negative 2x squared minus 7/3 x equals negative 1. Let's give this a shot. So the first observation, maybe the most frightening thing in this equation is what? It's that fraction, right? We have a division by 3. It's totally fine to just solve this using the quadratic formula, in which case your b value is negative 7/3. It's okay. That's what it is. It's negative 7/3. But that b, remember, is in 2 places in the quadratic formula. And so you're going to have fractions throughout every single step in the quadratic formula if you do this. I'm going to give you what I think is a better option. And the better option is to get rid of those fractions right from the get-go. What you are allowed to do is multiply both sides of any equation by any number. What's the magic number that's going to clear this fraction? Is 3. So we're going to multiply both sides. I'm going to copy that equation right up here. Negative 2x squared minus 7/3 x equals, leave a little tiny space there, whoops, equals negative 1. So there's your equation. And we are going to multiply both sides of this equation by 3, which is a legal thing because we're doing the same thing to both sides. Okay, on the left-hand side, this 3 is going to come in and it's going to distribute to both of the terms. When we do the 3 times the first term, what do we get? That's negative 6x squared, right? Negative 6x squared. When we do the 3 into the second guy, it just cancels 3. I've seen people do a lot of funky things. The whole point of that 3 is to cancel this 3. I see people do this. 3 comes in and hits the top and makes 21, and hits the bottom and makes 9. That is not what the 3 does. The 3, I mean, if you really want to multiply it, that 3 is on the top. It is not on the bottom. And so the bottom is never going to change. But anyway, the point of putting that 3 there was so that we could just straight cancel it right away with that 3 in the bottom. So what's left when I cancel? It's just a minus 7x. Equals, another common mistake is to keep that negative 1 as a negative 1, but it changes. Everybody changes. What is this? Now it's a negative 3. Okay? Okay, and in order to solve that with the quadratic formula, we still need a magic number on one side. What is that magic number? 0. So let's add this 3 to both sides. Negative 6x squared minus 7x plus 3 equals 0. So there's our equation in standard form, right? Okay, so we're going to finish solving this equation together at the start of our class on Thursday. The homework for this one is not assigned. The calendar has the correct due dates for homework and all that. So yeah, just the first one that we did today, 22, is that what it was? Yeah, so just 22 for next time. I didn't get a chance to check homework today. Just bring it to me next class. If you really want to, you can check it off with me right now.